So with that, I think today's session, the whole session, I was just planning on playing with the ChatGPT. I've answered all the questions. I've done everything, and really, I the first couple 3 years of running virtual class session classes for virtual class sessions for this class was really filling in the gaps, doing some of the simulation demos, desktop lectures. I've done that, and as I was sending out this message, I checked, I did all the questions. There may be one or two problem sets where there are still questions for me to do as they come up. As I do the check, I'll be able to see them. So this is really what I have to kind of fill up the remainder of time. And, and I think I am actually interested in seeing how well ChatGPT does with the modern physics material. Last year, I guess I wasn't doing problem sets, but with the conceptual questions, which you don't have this year. Conceptual questions, really, modern physics is where ChatGPT had the issues, but so far it's been doing well, so I don't have any reason to think it won't do well. But let's bring up problems at 10 and just work through some questions with the help of ChatGPT. As using it as a tutor, not the way you've seen me use with. Oh wait, that I don't know if I meant to have this most to contribute, but I'll do that. That one I might do off screen just to make the video editing easy. Yeah, let me do this off screen. So um, I guess for this class I'm having to do this because this is in the middle of a required module. I just clearing module requirements for the test student. And once, I mean, this right now it's fine, but once I click reply, it'll show the people who are in the classes their replies. So I gotta kind of it- for the orientation session, I had something similar that was on the shared screen, but then I had to blur out the names. It's more work for me, so let me just to get it off the screen and get it out that way. And so. I've cleared all the module requirements from the previous week. I've said this before, right? Test student is my worst student. He never does anything he doesn't feel he has to do. But he's the kind of student who the instructors will hate, but still need to give an A to because he still does know all the physics. I had a friend, I guess he was maybe 2 years my senior in college. He was describing on engineering class he was in. Like, he's. So he never attended the lecture, never attended discussion sections, but he did well enough on the exams that he got an A. But whenever he met with his GSI professor, they would, um, they would have that expression on their face, like I hate you. But if you know the material, then you know the material. That's a test student because he is my alter ego, so he does know all the physics, but he's not a model student in any sense of that word. He doesn't do the things that I wish people would do, which is watch the lectures, read the textbook, think through the questions carefully, and sometimes when people don't do that and don't know how to solve physics problems, then sure, I can just not give you an A. But um, when you don't do those things but still know how to solve physics problems, then that's where, with the graded teeth, I have to still give you the grade that I have to assign according to my syllabus. So with that, let me start with the proper prompt. I could have just pasted in the question here, but you've seen the demo. You know what happens. So I'll say, "Hi, I'm working on my quantum mechanics lower division class, and um, and I'm working through a problem set that I'll need to um, work through with my instructor again later in our required one-on-one meeting. So I really need to learn the material. With each question, I'm going to try going through it myself, and when I get stuck, I'd like to ask for your help. Would you please help me learn by not giving me the answer right away, but just help me with the step I stuck on, please? Wait, that's the question. um, and it'll acknowledge. And let me find some more substantial questions to ask. Now, I think I might have mentioned this in our last class session. One of the kind of downsides of this modern physics material is the level at which I would like to cover them, and you see that approach in the lecture is there's a discrepancy or disconnect between level at which these questions have to be from level at which I'd like to you to understand the material, because these are kind of a dumb grading system where the answers have to be simple numerical or algebraic expressions. So the questions tend to be at a relatively shallow level, as opposed to homework problems in like upper division classes where you write out your solution and you can rely on a human grader to read it through and grade it, giving you partial credits and whatnot. um, so, a lot of the questions in the problem set are easier than I would like. Um, I'm actually looking forward to a future maybe where when we can have automated grading that's maybe based on something like generative AI, then I can imagine the questions kind of being able to have more robust questions where you kind of show you have to show your solution steps and all that. But these are the questions we're working with this semester. So um, all right. So photoness. So this is easy enough. So let me skip that. And let me just find maybe 3 or 4 substantial questions and try to do those. Uh, so this can be an interesting question. Let me look at the next one. Do I do Maybe I don't do anything relativistic. So this can definitely be answered non-relativistically. So let me try asking ChatGPT this. So I tried answering this question the way I did question 1 with E equals wait, can I even pretend that I did that? So question 1 with the E equals HF, and um, P is equal to, or and the wavelength lambda is equal to, um, and try to do this calculation. C is equal to F times lambda, solving for lambda in my head, C divided by F. But I'm stuck because they didn't. Uh, so from here, I could potentially. Oh yeah, yeah. I think if I can do it that way because they gave me E, I can work out frequency, and then from that frequency figure out lambda, and it'll say it's wrong. So let me work that out. So that's basically the answer it would be if this was a photon, not an electron. So I can say my let me use Wolfram alpha. I don't want to look up constants. Um, so I can do this. From the given energy, I can work out frequency, which is gonna be equal to energy, 18 kilo electron volts, divided by Planck's constant, that's frequency. And then for wavelength, I say speed of light divided by the frequency. and it'll give me an answer that I can plug in, and it'll say it's wrong. So in picometer, 68.88, 68.9 picometers. I tried answering the lambda, but um, the system says my answer is wrong. I don't know why. Not a question, but ChatGPT is usually helpful enough that it'll answer the implied question. Um, Tell me what I did wrong. Um, I mean, the hint is right in the question, de Broglie wavelength. Just look it up. Use P is equal to H over lambda. So work out P first and then so on. When ChatGPT answers, let me try playing a little bit dumb and say, but I don't know the momentum. So just remember that, yeah, only for photons. You gotta have a massless particles for that. For particles with mass, yeah, you use de Broglie relationship. Uh, oh, wow, it's giving me all those steps. Mm, Let me just hyper focus on this say and say I have to worry about relativity stuff. Let me just see what it says. That has nothing to do with solving the problem. Get something on the order of 10 picometers. Ah, interesting. Let me just try putting in 10. But if that's not correct, then all right, it's giving me some help. So I see, yeah, yeah. So that means not within a few percent, and in fact, even better than that. If it only got you, if it didn't get you within 1%, the system will grade you as wrong. So I'm pretty sure it's actually for the momentum, it's better than 1%. So, but let's give it a try. So, um, I think, yeah, P is equal to square root of 2mk. I guess I should actually just side by side. So, wavelength is equal to Planck's constant divided by the momentum that I'm gonna put in. And you should take your time, make sure that you understand this reason for these and the algebra for these. Just taking a little bit of shortcut, square root of times 2 times electron mass times the kinetic energy, which is gonna be this 18 kilo electron volts. So that should be in weight meters, yeah. So 9.14 picometers. Let's hope that's within 1%. Yeah. So if it's not, it wouldn't have been graded as correct. So, ah, um, um, graded it as correct. So it must be within 1%. I am curious if I programmed this in with a relativistic expression. Um, there's a chance that I didn't. Let me just to check. Sorry, I'm just, this is a bit of a distraction, but I am curious if I, uh, programmed it in with a relativistically correct expression. Because it on the off chance it's like more than the relativistic and non-relativistic expressions are more than 1% apart from each other. Because if that's the case, then right. So this is the question programming. Yeah, that's the chapter and the reference, and yeah, I did do relativistically correct expression. Yeah, 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 yeah. Yeah, so it must be within 1%, because otherwise the system wouldn't have graded it as correct. So All right, so let this wasn't all that substantial of a question, but let me look for ones that are. Oh, right. Because logging in as an instructor messed up the login thing I had. So let me resume. Um, the broad wavelength of a proton with a follow. Yeah, so wait, not yet. I think the other question might be trying to get you to question. Do I ever do anything relativistic? Because these are not gonna be relativistic either. Proton has rest energy of close to 1,000 MeV. So um, this is very similar to the question we just did. In fact, you can even do this. It's so similar that you can take this O from alpha expression, do a simple substitutions here, you know, instead of electron mass, say proton mass, and instead of the energy they gave me before, say 2 MeV, and like it'll just work out. It's This is what I mean, it's a little bit too easy, too superficial. I guess that's the right word. Um, and I wish I could ask more substantial questions, but let's see. So in picometers, 0.000, I think, 8403, maybe. Let me just say in PM. Too many zeros. Yeah, I thought I had too many zeros. Yeah, it's easy. All right. Same formula, just incredibly small number. um, it's multiple choice, so you could technically do this. Oh, so let me demonstrate another proper use of ChatGPT. Let's say you did do exactly this. You didn't quite understand the Bohr model, didn't, but because you got only three possible choices and you got hundreds of tries. You just tried every one of them, got the correct answer. You know that's the correct answer, and you don't know why that's correct. This is the kind of situation where ChatGPT can help. It can help you understand the correct answer. So I'll ask. So I got this question right because it's a multiple choice and I had 100 attempts. Stupid instructor letting us have so many attempts. But I don't understand. I don't understand why the last choice is correct. Help. ChatGPT will probably just ignore that insult, because it doesn't relate to what I'm asking it to do, and then explain. So larger values of n means a bigger energy, which means higher frequencies, so shorter wavelength. Uh, Wait, what? No, wait. Wavelength is shorter. Oh, no, 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 no. This is about kind of adjacent levels. So that spacing gets smaller. So smaller energy, so longer wavelengths. Yeah. Yeah, so you're calculating this. I misread it first time and thought it was going from n was the level it's coming from, and it's going to, I don't know, ground state or something, because I wasn't reading carefully. Um, yeah. Um, yeah, so you can kind of imagine using L'Hopital's rule. So the numerator goes as linearly in n, denominator goes as a fourth power in n. So as n goes bigger, gets bigger, this is number's gonna get smaller and smaller. So yeah, so carries less energy means lower frequency, so longer wavelength. Yeah. And yeah, it ignored my insult. So because not really productive addressing it. So let's find maybe a couple questions, ones that are have more meat to it. Maybe it's possible that there really isn't, because these are all once you have the formula, it's easy. So um, yeah. Oh, this could be more interesting. So yeah, let's do that. The here's the interesting thing that I could have ChatGPT's help with. I don't really need the help. So in terms of like angular momentum and all that, hey, I can just do the calculation. So n equals 6 state using Bohr model where angular momentum is quantized as n times h bar. Then it's a 6 times h bar reduced Planck constant, and Wolfram alpha will give me the number 3.949, and then the kinetic energy. So you know the total energy from the Bohr formula. Minus 13.6. That's the number I have memorized, and this is the hydrogen divided by 6 squared. So minus 0.3778. And the interesting thing is that there's a relationship between total energy, potential energy, and kinetic energy. The kinetic energy is going to be just this number, except positive. And you can get from the expression for the total energy that the potential energy must be this double. So minus 0.7556. Now, those are all correct answers. And now that although that's not hard, the thing that you can get help with is what I mentioned offhand in some of the videos. So for this question, the instructor said something about virial theorem that explains the coincidences between the total kinetic and potential energies, but he um, moved on without expanding on that, and trying to read about it in Wikipedia wasn't helpful. Can you help? Ken? And this would be where you're actually going above and beyond what the problem set asks you. But let's say as you're working through the problem set, you got interested by something, and none of the my lecture videos actually explained enough. And when you try to look it up on your own, sometimes not all materials are written. Like Wikipedia is written at a certain level that's sometimes accessible, sometimes not. Depends on the article. And virial theorem, I don't think your textbook covers. So it's a kind of upper division analytical mechanics material. So where would you have that explained? um, yeah. So the numbers we calculated, yeah, there are these ratios here. There are coincidences. They are mandated by the virial theorem for an inverse square force, like gravity, Coulomb force. Okay. Now, it probably won't prove the virial theorem. I'm not sure if I can prove the virial theorem, but there's a statement that says where the potential is the power law form of that. Yeah. So it's basically covering all central kind of central force potentials. This so the most common one would be where k is equal to -1, the inverse square law, and you could also have like spring force. That's where k would be 2 for spring potential, and it can be proven either in quantum mechanics or classical mechanics that there's this relationship between potential, and T is a kind of more upper division-ish letter for kinetic energy. Oh, did it not explain? Yeah, let me, sorry, I'm a little bit lost from above. What is T? And this is the kind of thing that, you in on as you are reading through a Wikipedia page, if seeing this confused you, like what else can you do? Like if you haven't read a textbook that uses a T for kinetic energy, it's super unintuitive letter. That's why I never use it when I lecture. And most lower division instructors won't do that. But you can ask a ChatGPT and it'll explain, oh, that's just a symbol for kinetic energy. Yeah. Average of the kinetic energy. And I can ask, um, oh, that's so confusing. Why T and not K or KE? Maybe it'll give me a historical lesson. I actually don't know the reason why it's a T. It could be that it's yeah, Lagrange mechanics, yeah, but um, yeah, again, upper division. But so this could be notation dates from some seminal textbooks or like classic textbooks in that area back then. Yeah, maybe. Yeah, just inherited habit. Yeah, sure, why not? Yeah. So let me go back and keep reading. So yeah, numbers. The thing that's confusing here is ChatGPT is within its own text. It's mixing up, kinetic for K, and then shifts to T, and then goes back to K. I think later. But sometimes you gotta uh, keep uh, kind of keep up with the um, author shifting notations. So anyway, so this is a statement that can be proven and is proven in textbooks. I wouldn't attempt proving it myself, except maybe so with the special cases you can think of like a circular orbit of a satellite in a gravitational potential, that you can do that. And I think that you could even um, you in the special case of a circular orbit, you could do it with a general parallel form, I think. But this is when this virial theorem goes applies more broadly than the special case of circular orbit. Like if you have an elliptical orbit or orbit that doesn't have a closed form, as long as you look at the average kinetic energy and average potential energy, this relationship still holds. That's what's proven in like analytical mechanics or upper division quantum mechanics. Yeah, so gravitational K is equal to -1. Plugging that in gives the kinetic energy is twice the negative of the, or sorry, kinetic energy is negative of the half of the potential energy. Uh, I guess that's right. Yeah, yeah, yeah. So, add what? Sorry, gives this when you add t to both sides. I don't think that makes sense. Yeah, yeah, yeah. Let me point that out. Um, uh, okay, going back above where you say the t to both sides. See screenshot. I think if you do that, you get 3t is equal to t minus 3. No? Yeah. It'll probably correct. The operation you need to do is I mean, so there's an expression you're trying to get to. You are trying to get to the expression for the total energy. So you add 2v to both sides, or I guess add minus t plus V. Yeah, minus T. Then the left hand side becomes this, and right hand side becomes this. Yeah. Let me look at ChatGPT's thing. Going there. Yeah, good catch. Yeah. Imperial theorem. Okay. Yeah, it didn't acknowledge its own mistakes. Um, they're not adding T, but we can still go through it. From here e- to equally convenient options. All right, solve it for. Or I guess you could do both. Um, yeah, yeah, these identities. Yeah, yeah. Add V, not T. Yeah, yeah. It's and then so yeah. So that phrasing is just wrong. Like you can see it here, and as you read through, you can see, all right, that's not the operation that you were talking about. But let's not be difficult and argue with the ChatGPT. Um, so first serial theorem. Yeah, statement. Yeah, so that's the relationship. The total energy is negative of the kinetic energy or half of the potential energy for this specific case of k equals minus 1, which is the case for the inverse square law. Inverse square in terms of the force. So when you derive the potential energy, the exponent there becomes minus 1. So yeah, and this is the more lower division kind of approach where you can kind of see that why does the theorem exist? Um, I mean, that's not why, but um, but yeah, uh, that's not why. But I don't know where it's. I was never much of a theorist, so I don't know where virial theorem is actually useful. But it gets mentioned, and I'm sure if you do more theory work, there are times where it's more useful than giving you these nice relationships between different forms of energy. Um, yeah, good. All right, let's see if there's one other question I can do with the help of ChatGPT. Oh, this can be fun. Yeah. So let's say you didn't look at the hint and let's say you just tried plugging in the answer you would get using the regular Bohr model, which should be minus 13.6 eV. Let me calculate the energy of the photon and then divide it by Planck's constant. So the energy of the photon should be the excited state 1 over 3 squared minus the ground state. That's the energy. It should be a positive number, and I'm dividing that by Planck's constant. Um, so 2.923 hertz. It'll be wrong. 2.923 E 15 hertz. Again, still wrong. And I asked ChatGPT. I used the Bohr model, Bohr formula. What's wrong? Can you help? I used the Bohr model formula for this question, and it says it's wrong. I double checked my calculation and tried putting in more significant figures, all the things that don't help you. Because you have to basically go to the analytical expression for the Bohr energy formulas and replace the electron mass with the muon mass, or replace that with the 207 times electron mass. Or you could, if you get the Bohr energy formula, you can use a scaling relationship. Let me see if ChatGPT will give me the energy formula. Then you can just, uh, yeah, you have to kind of imagine doing that. all that formula stuff. So for hydrogen-like system, yeah, this is the full expression. The mu is probably the, yeah, that's the reduced mass. Um, yeah. So now with the muon, proton is not much heavier. It's only proton is only like well, it's like it's still 10 times heavier. But one thing that I yeah, it's possible that the question is not. So let me try this with the muon mass. So if I do it with the muon mass, then so here it goes linear, energy goes linear to mass. So with this, if I just multiply by 207, I would get the answer I should get with uh, just the muon mass um, replacing the electron energy. And I think that's actually a wrong answer. It's wrong theoretically. I mean, it's maybe correct in terms of what's expected. Because let's see if your textbook does the calculation with um, if it shows the reduced mass in the formulas, or if it just does electron mass. Yeah, it doesn't do reduced mass, so it's probably never come up because I am using the textbook formula, but physically it's not correct, especially with the 1% tolerance. So if I use let me work out the fraction for the reduced mass, which should be so muon mass times proton mass divided by muon mass plus proton mass, and then divided by electron mass. Since we are kind of dealing in units of electron mass, then this is 185.8, 185.8, and if I use that, I'm pretty sure that won't be graded as correct. So 5 point, because it's pretty far off, 5.431. So I think I want to fix that. So let me go fix it. So we have plenty of time at this session. So let's use the remainder of our time just fixing that question. To add that other solution as one of the possible answers. I don't think I would take away the other answer because that's the first answer I gave. That's the answer that people will answer most commonly, and it's just based on the textbook's expressions, so that needs to be graded as correct. Otherwise, I'll get too many complaints. But for the benefit of someone who knows more physics than I give people credit for, I really should make sure that this question does treat physically correct answer as being correct. That's the question code. Oh, okay. I didn't grade it. Someone else wrote it. That's why. So I'm gonna put in an alternate answer, and I'll put it on the top. Yeah, the relative tolerance is not enough. In fact, I can just go down to one because the again reduce the mass is so far off. 5% one. So today's date, April 25th. Reduce the relative rel tolerance to 1%. 5% doesn't help with the difference from the reduced mass version, and added the frequencies calculated using reduced mass as one of the correct answers. So, all these. Oh yeah, the 207. So I'll have to. m mu or mu mass is equal to 207 in units of electron mass. Reduced mass is equal to, now program this in as just a numerical factor. Does the question say to, does this, uh, I think this is the part that uh, you would use to justify the answer. But let me just double check one thing. 163. If that's a textbook's phrasing, then I'll keep it while still programming in the what is physically correct answer. If that's not textbook's phrasing, then I'll take it out because that phrase doesn't need to be there. Oh, yeah, that is textbook's phrasing. All right, I'll leave that in, but I'm still gonna finish what I was gonna do. Um, all the textbook or all the question phrasing does authorize use of muon mass only. Um, so this one is 185.8 in units of electron mass. So it's a reduced mass um, mu times m proton divided by m mu plus mp Newton applicable when muon and proton orbit about their center of mass. So I think I'm getting rid of that. So there's E delta 1 with mu mass, and there's E delta 2 with reduced mass, and answer is going to be, oh wait, I have F1 which is E delta 1 over H, F2 E delta 2 over H, and the correct answer is both F1 or F2. Well, not both, but either or. Oops. Mexina needs numeric input. Oh, um, so this will be 4, 1. The answer will be that. Oh, that. And yeah. So with the version I had, if I put in so 5, then that should be 5.87. Yeah. So 5.87 is 17. It'll grade it as correct. So, anyways, yeah, it wasn't so much of a ChatGPT. Again, my biggest problem with these problem sets are they are too easy. The questions are too easy. So so that's why I watch the lecture videos. Lecture videos cover everything at the level you ought to know. And let me just finish this with the correct answer here. I mean, oh, I guess I can actually just resubmit the exact same answer and, uh, well, change it a little bit and submit it, and it'll grade it as correct because I changed the underlying question to this. So that, yeah, I think a textbook did with this phrasing they did mean for you to just use muon mass because so this is the kind of thing that it's really written for people who know too much of physics because otherwise you'd read it and think, oh, what is that about? This just means you don't have to use the reduced mass. With the electron, not using reduced mass made perfect sense. It's like 0.5% correction, 0.5%, or even less than that, 0.05% correction when you use electron mass rather than to reduce the mass. But with the muon being so much heavier, that begins to matter. But this assumption says that just to use the muon mass, even though it's going to be off by like 10%, 20%. So, all right. So I think that's everything. Although we have some time, again, the question is said it's kind of easy, and I want to end the session early. So, um, so let me end the session here.